Hello and welcome back to the next video on atomic theory, reviewing for the North Carolina Physical Science Final Exam. Coming to you again from room 405 with Mrs. Walton in the Science Hall. Alright, so we covered this at the end of the last one, but let's talk about it again. What's an ionic bond between a metal and a non-metal? That means opposite sides of the periodic table. Let me try and make my writing a little bit smaller here. Let's get it together. There we go. And what we didn't talk about last time was how they make a bond. Now, ionic compounds make a bond by transferring electrons, or in other words, by becoming ions. Do you remember what ions are? They are cations, which are positive. This means they lost electrons. And anions, which are negative, and this means they gained electrons. Now, what tends to become a cation out of these two? Well, look at your periodic table. Those guys on the left side are going to lose electrons in order to become like a noble gas. So those guys are going to be the ones that get positive. So metals are the ones that get positive. So we'll just go ahead and put that there. And what would become our anion here would be the guys on the right side who want to gain a couple electrons in order to turn into a noble gas. So those are our nonmetals. Okay, so now let's think about metallic bonds. So metallic bonds are between two or more metals. And the way that these guys make a bond is by actually having a sea of mobile electrons. And we'll talk a little bit more about that here. So what about covalent? Covalent, if you recall, is between two or more nonmetals. And these guys form bonds by actually sharing electrons. And when they share them, that means that, let's say we have two oxygens, they decide that they're going to keep the electrons between both of them so that they're both happy. And we'll talk a little bit more about that in a minute too. So there's a brief overview of our bond types. Let's go more in depth here. Okay, so an ionic bond will always have two oppositely charged ions. So either a metal and a nonmetal, or a metal and a polyatomic ion, which can be found on the list on the back of your periodic table. Why would they want to gain or lose electrons? Well, this goes right back to that octet rule. Everyone wants to have a filled outer shell. Now, how about covalent bonds? Do these guys have charges? No, they don't, because they aren't transferring electrons, they're sharing electrons. Instead, they're kind of making a deal with each other that if they share these electrons, they will both have that full outer shell and fulfill the octet rule and be happy. And lastly, we have the metallic bond. Remember, it's between two or more metals, and their electrons are a sea of mobile electrons. Now, we should also touch on alloys. Alloys are a mixture of metals, and we make them in order to create a more stable substance, or a substance that meets our needs, such as white gold, which is gold plated in another metal. And the reason we do that is to make stronger metals, or to make metals for different industrial purposes. And remember, their electrons move around in a sea. Okay, so let's think about ionic bonds for a minute. First of all, let's look at sodium chloride here. Sodium is on the left side of the periodic table, number 11, and chlorine's on the right, number 17. That makes this an ionic bond. The way that we can know that it's an ionic bond is simply by checking our periodic table. So make sure you do that every time. But what literally happened was our sodium lost an electron and became that positive cation we talked about. On the flip side, our chlorine gained an electron and became that negative anion we talked about. Because they're opposites, they're going to attract, and an ionic bond forms between them. Here's a great example of how it works. Sodium only has one electron in its outer shell. It removes that shell, or removes that electron, and loses its entire shell. Then chlorine's going to accept the electron and it will act the same as that noble gas it's trying to become, or it will have that full outer shell it desires. So let's watch how it happens. First, sodium loses its electron to chlorine. Chlorine's happy now. They have opposite charges. Okay, so now there's a full outer shell here, and my sodium's outer shell is going to disappear. And then they're going to have charges. Now sodium's positive and chlorine's negative, and what do opposite charges do? They attract. So a bond forms between the two of those, and we have an ionic bond. Now, in a metallic bond, the electrons aren't held very tightly. They're allowed to go wherever they would like, and we call it a sea of mobile electrons. This is what makes them ductile, malleable, great conductors, shiny, all those things we know about metals. So here's an example of how these electrons move around. Our positive ions are staying in the middle here. We have some copper, and the electrons just go do whatever they want in that sea of electrons. Lastly, the covalent bond. The way I figure this one out is by drawing these Lewis dot structures. Remember those? Chlorine's in group 17, so he'll have 7 valence electrons. We put 1 on each side and then double up, and they end up with 1 freebie each. Guess how many bonds they're going to make? Just 1. So the chemical bond that forms between 2 nonmetal atoms is always covalent, and there are no charges. There can be single, double, or triple bonds. What do they do with their electrons? Do you remember? They share. So here's what happens. They share. They're both happy. They have a full outer shell, and they're just sharing electrons, and it turns into Cl2. Here's a good example of how those electrons move around in water. Here's oxygen with its 2 in the inner shell, and it's 6 in the second shell, and hydrogen had its 1. Well, hydrogen wants 2, and oxygen wants 8 in its outer shell, so they're going to share them. And those electrons are going to move throughout, all crazy, and everyone's going to be happy. Okay, so how about naming these guys? If you remember, in an ionic formula, we have to crisscross. Miss Johnson put this song in here for you all, so you could laugh at how old we are. You know you should know better. Crisscross is not having anything today. As we stand here totally crossed out, we commence to make it up. So that's a good way to remember what you have to do in an ionic formula. You have to crisscross the oxidation numbers or the charges. Okay, so here's an example. Sodium carbonate. Look at your periodic table and find sodium and determine what his oxidation number would be. Sodium's oxidation number would be +1. So we have Na, and he has an oxidation number here of +1. Bear with me, I'm going to write it out on this one. And then we have carbonate. Where do we find carbonate? Well, if you flip over your periodic table, you'll find carbonate, and he is CO3. Actually, yep, this one's on your list. CO3, and it's actually a little 3. What do we call that thing? Do you remember? We call it a subscript. And what is his charge from your periodic table there? If you look, you're going to see that he has a charge of 2-. All we do is we take each of these, this is a +1, and we crisscross them or drop and cross them. Drop your charge, cross the number, and I'm going to end up with Na2 CO3 1. That looks horrible, but hopefully you get the point. Since it's a 1, we don't have to put anything there, so that's sodium carbonate. Then we have gallium chloride. Find gallium on your periodic table. Take a look. He is in group 13. So what is his oxidation number going to be? Ga is going to have an oxidation number of +3, just like aluminum. And chlorine is in group number 17, so he's going to have a 1- oxidation number. What do I do with those? I drop the charges and I cross them down, and I end up with 1 gallium, Ga1, and how many Cls? 3. You can do the same thing with lithium fluoride and find lithium in group 1 and fluorine in group 17, and you'll end up crossing and dropping your charges and getting LiF. Okay, so that's how we do an ionic formula. First, we had to make sure these guys were either on opposite sides of the periodic table, or one was a polyatomic ion. Now, what about if it's covalent? We have to consider, first of all, that their prefixes are telling us info we need to know. Di means 2, and mono means 1. So how many hydrogens do I have here? Dihydrogen means I have H2, and monoxide means I have 1 oxygen, so we have H2O. Then we have silicon, but he doesn't have anything in front of him. That's because if it's only 1 and it's the first element, you don't have to put anything. So we have silicon 1, and we have dioxide, so that means we have 2 oxygens, O2. How about this last one? Diboron, B2, tetrahydride. Tetra means 4, and hydride is like hydrogen with an IDE, so H4. Alright, so first things first, you got to figure out ionic or covalent, and then go from there. Alright, so here are some good steps for you. First of all, determine if it's ionic or covalent. If it's ionic, the name of the metal stays the same, and the non-metal's last 3 letters change to IDE. If it's covalent, the first non-metal stays the same, so like oxygen, and you add a number to the front unless there's only one of them, which would be mono. And your second step is that the second non-metal's last 3 letters change to IDE, and you add your number prefixes in the front. Let's review those real quick. For tin, our number prefix is deca. Okay. For 5, our number prefix is penta. I should go back one. For 2, my number prefix is di. For 7, it's hepta. For 8, it's octa. Now how about over here? Let's try these. For 6, it's hexa, like a hexagon. For 4, it's tetra. For 1, it's mono. There's 2 again, di. And for 9, it's nona. Okay, so it's a good little quiz for yourself there if you want to go back and pause it and see if you can remember those. Okay. So first of all, let's practice here looking through this whole list and saying ionic or covalent. Find sodium and find carbonate. Sodium, carbonate, sodium, carbonate. Sodium is a metal, carbonate is a non-metal. So I'm going to go up here and I'm going to mark it metal, non-metal. Okay. And then I'm going to go to the next one and find phosphorus. Say phosphorus is on the right side of my zigzag, non-metal, and oxygen is a non-metal. Okay, I'm going to do that for all of them, and then I'm going to go back and I'm going to say, okay, a metal plus a non-metal gives me what kind of bond? Ionic. Non-metal and non-metal gives me what kind of bond? Covalent. Okay, do that for all of these, and in the next video we will talk about how to name those guys as some quick review. So pause it here, write all these guys down, and try to name them, and we'll have your answers in the next video.